This is an example of add, and you can use in future. What is the function for add? You know, when you have add, you have to pop out two values and then you get their sum. And if it's okay, so we push the result, the sum, to the step for using in future. So over here, you have to pop and add for this function. But if it's yet, it's okay. After popping the first value, you go to the second pop to read out the second value, and then you get the sum, and then you use the subroutine rank checking to check if it's okay, so we can push the result to start and then we return. But we have some problem, maybe you don't have the first value at that time we return, and the second value has a problem. At that time you have to put back the first value, and after popping the second value, okay, and we get the sum, and over here if it's no, at that time we don't use the two values, so at that time we have to push them back to start and then return. And over here we have the program. You know, when we go to the program, so firstly you pop subroutine to the other value and then we check it. If it's not okay, so we go to exit. Okay, because you know when the subroutine, when it's 0 is okay, so we keep going down, but if it's 1, so we exit. Now when we keep going down, so over here now you need to prepare the location for the second value. So over here we assign 0 to R1 with the add. And when we come here, you have the same function for this. Okay, we check it. If it's not okay, so you need to go to restore 1. When we go to restore 1, that means you want to restore the stack pointer to point to the first value. So over here you need to decrement the stack pointer to point to the previous value, the first value. Okay, but it's okay. That means we come here to get the sum between the current value in R0 and the first value in R1 over here. R0 now is storing the sum. But you know, we have to check the range, so we go to the subroutine range checking. Okay, in the subroutine, in fact, you don't see the subroutine range checked over here, but that's on homework. Okay, so you know, when you go to the subroutine, you will see if it's 1. Okay, in a register, if it's 1, that means you could use the location to store the sum. Okay, so at that time, so you have an error. So we go to restore 2 to restore the value for the stack pointer to point to 2 values. And when we come here, it's okay. So you pull the sum to stack. Okay, and then return. You know, now we go to the problem for data conversion. You know, for example, when you trap 33, you input two values 2 and 3. So what did you have? Can we get the final result file for the sum? In fact, no, because over here now when we enter when you trap 33, so we enter 2, that means the digit 2 with the ASCII code 32 has 3, 33 has, and then we get the sum. That means we have 65, not 5. Okay, so it's wrong. So that's the reason why you have problem for changing, for converting the data time. So over here, firstly, you have ASCII to binary. Okay, ASCII to binary. ASCII, this is the ASCII value. Okay, the ASCII code. When we input 2, input 5, okay, input 9, so we have the ASCII value. And you want to convert them to its value. So we have 2, 5, and 9 for computing, for example. And for getting the value 259 if we want. Okay? For example, if you want to input 259, that means you want to have the value 259. So at that time, when we use trap 33, we couldn't get the value 259. Okay? And you have some tool before going to the subroutine. So over here, if you want to get the value 259, so at that time, how can we get 200? Or how can we get 50? Okay, so there are some techniques. Okay, so over here there are two techniques. Okay, how can we multiply a number by 100? Over here, the first way, you have to add number to itself 100 times. On the second approach, you can add 100 to itself numbers times. Okay, it's better when the number is less than 100. Okay, and we have a table storing 10 entries from 0 to 9. Okay, with the entry 0 you have 0, entry 1 you have 100, 2 200, etc. to 9 900. We have the problem. We have the same problem when you want to get the problem for 50 over here. At that time, you use the second table for storing 10 entry from 0, 0, entry 1, 10, entry 2, 20, 3, 30, and 9, 90. Because that means you have two different tables. Now you have the code for lookup table. What is the function? You want to multiply a 0 by 100, and we use the ways of a lookup table. Okay, so over here we can define a table, so we call it lookup 100. Okay, we have 1, 2, 3, we have 10 entry from 0 to 9. So we have the value 0 to 900, entry 0 to 9. Okay, and look up the 100, the label. So firstly, you assign it to R1 with your area. Now R1 is storing the address of the table. Okay, and now over here, if you want to get the result, the multiplying, we want to get the multiplication between R0 and 100. So over here we have to add the index. Okay, because you have R0, you have each value. Okay, now you have to add this to R1. Each line of offset. Okay, now you have the sum. The sum over here is at a class that's a pointer to the entry. For example, now R02. So now R1 now is storing the address of this entry. Okay, so at the time it becomes the base register. So we go to this location to the other value 200 and we assign it to R0. Okay,